This is science writer Kristina Campbell interviewing leading scientific experts to get answers on the microbiota-gut-brain axis. So often in the microbiota gut-brain axis, scientists I know use different animal models to figure out what's happening in humans. And you used a really unique model for your study, the marmoset. What are marmosets and how can they tell us something about how humans behave?
Yeah, sure, absolutely. So marmosets are non-human primates, technically monkeys. Um, they are New World primates. As a biomedical animal research model, they have a long history in neuroscience research. They're as compared to a rhesus macaque, for example, the most popular non-human primate animal model. They're much smaller, which means they're easier to house. They have cooperative social behavior. So, particularly in terms of parental behavior, males and females share the weight of we call it biparental care, which is unique and reminiscent of what happens in human society. There are other things as well, but those are some of the highlights, I suppose.
Mhm. And so how did you change the marmoset's gut microbiomes in your experiment?
Right. Yeah. So in this case, we call it antibiotic induced dysbiosis. So we use an antibiotic cocktail. Um, in order to do this. So we chose these specific antibiotics because they target both gram-positive, gram-negative bacteria. They have minimal absorption into the bloodstream, so outside the gut, and then their inability to cross the blood-brain barrier. That's because there has been work done in the past to show that some certain antibiotics can have an effect on on the brain, and so we wanted to pick antibiotics that we're having an effect on the gut microbiota and then the microbiota's effect on the brain or cognition.
And I'm curious about the dose of antibiotics. Is this something like way beyond what a human would have gotten?
Humans wouldn't receive these three drugs in a cocktail. However, independently, at least two of the three humans would receive. I would say that this is a higher dosage than would probably be used therapeutically. I guess it would depend on what your therapeutic avenue was. But I would say overall, yes, it would be a higher dose than would traditionally be used therapeutically.
And what did happen? What changes did you observe in their behavior or their physiology?
Yeah, so we saw a number of changes that were interesting. We saw changes in concentrations of gut bile acids. We saw changes in functional pathways in the gut predicted by shotgun metagenomics. We also saw changes in concentrations of fecal metabolites that are relevant to gut brain axis communication. So things like short chain fatty acids, but also some key neurotransmitters and amino acids as well. And from a behavioral standpoint, we saw that we did see some behavioral changes associated with the use of antibiotics. One other last thing that we did see was that we didn't see any changes to baseline cortisol concentrations between antibiotic treated and non-antibiotic treated marmosets. However, what we did see was we saw differential responses in stressor associated changes in cortisol. So, in other words, when we added a stressor in addition to the antibiotic, which we also considered a stressor, we saw changes, differential changes between antibiotic treated and non-antibiotic treated. But we did not see changes in baseline cortisol. One of the interesting things is that the specific behaviors we saw change are associated with affiliative behavior. And so, because marmosets have this can be socially monogamous, have this pair bonding that forms between a male and a female, that became or that could be really important as to why we may be seeing the behaviors that we saw.
So, what does this add to what we already know about the microbiota gut brain axis, say from rodents?
To the best of our knowledge, and particularly in the way that we did our study, we haven't seen that done in a non-human primate model. So from that standpoint, it's novel. Another thing is that as one might imagine, in terms of the evolutionary relatedness, you know primates are more evolutionary related to humans than rodents, and so I think it is a step forward for that reason. And then going back to some of the things that we said about why marmosets have been an attractive model, for research, those reasons as well. So things, for example, like some similarities in social behavior between marmosets and humans. Also, to the taxa that were changed, and as a consequence of antibiotic administration, it's different than what we've seen in rodents as well. So again, these studies that have been done in rodents where there has been antibiotics used as a perturbation to cause dysbiosis, and then look at gut-brain axis changes or changes relevant to gut-brain axis regulation or again dysregulation. In marmosets, we saw that the bacteria, the taxa that were changed were different than what had been seen in rodents. So again, one of the things is then that gives you a potential target to then look at further.
Mhm. Yeah, so what do you want to know next? Is it primarily about these specific bacteria that seem to be meaningful in your study?
Yeah, certainly that is one thing. So there's a number of questions that we're interested in looking at going forward. One is about the resilience of the microbiome. So following these study subjects out longer to see what ultimately happens in terms of recovery. You know, do they recover back to baseline or not? And then how does that correspond, obviously, with their behavior as well? So that's one thing. Some other things that we're interested in are, so we do want to look at the addition of an additional stressor. So what happens in the context um, of an additional stressor? Is that the tipping point, say for some subjects, maybe to be in a stressed or depressed or type of state, as opposed to maybe if antibiotics alone were not enough to cause that alone. So that's another thing that we want to look at. And of course, mechanism. We want to continue to try to dissect mechanism through these you know longitudinal like studies where we have a lot of data where we can try to make those associations, and then hopefully eventually gain some mechanistic insight.
Thanks so much for telling us about your study today.